What is the volume in milliliters of a 10.0 gram sample of krypton gas at 25 degrees Celsius and 575 millimeters of mercury? So this is very similar to the previous problem, if you looked at that one, where we are trying to convert between volume and amount in mass, right, which we can easily convert to moles. If this was at standard temperature and pressure, which is 273 Kelvin, and in millimeters of mercury it would be 760, or 1 atmosphere of pressure, we would be able to use the molar volume, 22.4 liters per mole. But this is not at standard conditions, so we can't do that. If you can't use the molar volume, that means you need to go through the full process of using the ideal gas law. And that is the equation PV equals nRT. That relates pressure, volume, moles, temperature together, and R is a constant called the gas constant, meaning just a number that you can look up. Okay, so we're going to use the ideal gas law to solve, and we're going to need to know what each of these 5 terms is for this problem here. Oftentimes when you do this, and what you're going to find for this problem too, is you need to do some conversion factors to convert units to get everything to match up well. So we'll kind of address these variables one at a time. Okay, first let's think about pressure. So let's see, where's the pressure that we're given? We're given a pressure in 575 millimeters of mercury. For now, that looks just fine, so we'll keep it there. What's the volume? Well, we don't know what that is. That's what we're going to solve for, right? So we don't know the volume. We're going to figure that out. What is N? N is the number of moles. Okay, am I given a number of moles? No, I'm not. I'm given a mass. So I'm going to actually have to convert this mass into a number of moles. So I can do 10 grams of krypton, and I can convert it into moles by doing a molar mass, this time with grams on the bottom, so it cancels. I can look on the periodic table and find the molar mass of krypton is 83.80 grams for every mole. Grams will cancel. I get 0.119 moles for my number for krypton, and that's equal to N. Okay. What is R? R is a number you don't have to memorize. It'll always be provided. It is 0.0821, and the units are complex, but we do need to be thinking about them. The units are liters times atmospheres divided by moles times Kelvin. Okay, these liters are important because these determine what will cancel in the rest of the problem. So we can see here, right, we're going to make our volume is going to become in liters. Our pressure number is going to have to be in atmospheres. Here it's in millimeters of mercury, so that's a problem. We'll have to change that, right, so it matches up with atmospheres. Moles tells us we need moles, so that's going to work. And this reminds us our temperature needs to be in Kelvin. So let's do temperature next, and we'll go back and make sure we change our pressure. Okay. So temperature is going to be, what, 25 degrees Celsius. It's not okay to leave it as Celsius. It needs to be in Kelvin, so we do plus 273, and that gets us to 298 Kelvin. That's good, right? So like I said earlier, right, our pressure needs to be in atmosphere so that it'll cancel with our R. It's currently in millimeters of mercury, so we need to do a unit conversion up here with this number to get that number in atmospheres. The conversion factor will be between millimeters of mercury and atmospheres. We want millimeters of mercury on the bottom, so it cancels. The equivalence tells us that there are 760 millimeters of mercury in every 1 atmosphere. This relationship here you can look up, or it'll be provided. We can plug this through our calculators to get what our pressure is in atmospheres, and it's 0.757 atmospheres. Okay? So before I plug, we'll take account of everything, right? Our pressure is in atmospheres. That's good. Our N is in moles. That's good. Our temperature is in kelvins. That's good. Okay? So it's all going to work out once we plug it in. So let's actually do that. Let's go ahead and plug. See what we get. PV equals nRT. Right? That will look like 0.757 atmospheres times an unknown V equals N, which is 0.119 moles R, which is 0.0821 liters times atmospheres over moles times kelvins. Temperature is 298 Kelvin. I can divide this over and then solve for V. I'll show you what that looks like so we can see how the units are all going to cancel nicely. Shoot. There we go. You know what I mean there. And we're dividing by this number, 0.757 atmospheres. Let's see what cancels. Moles is divided by moles here. See that? Moles are going to cancel. Atmospheres is divided by atmospheres here. That's going to cancel. Kelvin is divided by Kelvin here. Those are going to cancel. We're left in just units of liters, which is a unit for volume, which is good. We plug all this mess into our calculator, all these numbers, and what we end up getting is volume is equal to 3.85 liters. We could stop there, but the question asks specifically to give a volume in milliliters. So how do I convert between liters and milliliters? Another unit conversion. There's 1,000 milliliters in 1 liter. And so our final answer is going to be 3,850 milliliters as our volume.